Hello and welcome to this AMSIS training video podcast. My name is Daryl and today I'm going to take you through an introduction to Kerberos in OS X. We will be looking at what Kerberos is and how it actually works before having a look at some helpful troubleshooting tips. Kerberos, originally designed by the Massachusetts Institute of Technology or MIT, is a network service authentication protocol. It was named after the three-headed guard dog of Hades. This is quite accurate as Kerberos creates a realm with three key components. These are the Kerberos client, the Kerberos service, and the Key Distribution Center, or KDC. Apple has been using Heimdall's implementation of Kerberos version 5 since OS 10.7. But why use Kerberos? Well, Kerberos provides secure network service authentication, which unlike other authentication methods works without the need of transporting your password across the network. Kerberos works on the basis of tickets being sent between the three components. Passwords are stored in a central database which helps administrators to manage multiple users. Kerberos also helps overcome the issue in which users have access to multiple services with potentially multiple usernames and passwords. Kerberos allows users to gain access to all their services with a single password which only needs to be input once. This is commonly referred to as single sign-on. Kerberos is a background process which most users won't be aware of. So how does it work? Let's start from the beginning with what seems like a simple login. By authenticating as a user for login, this prompts a packet to be transported to the KDC. This packet contains the user's name but does not contain any password. This packet is a request for a ticket granting ticket or TGT. This TGT is used to gain access to all the user's Kerberos services. Tickets are timestamped and therefore do expire as part of the security in Kerberos. The request sent by the client will be checked by the KDC against the password database where it will try to match with a valid user. Once matched, the KDC will produce a ticket granting ticket. The TGT contains the user's name, the name of the KDC, the client's IP, and a session key. The session key is a time-sensitive encryption key created just for this session by the KDC. The encryption key changes periodically so that if it is compromised and decrypted, it can't be used on packets from other sessions. The TGT is then encrypted with the KDC's own private key. Only the KDC has this key, so the client never sees the contents of the TGT. The KDC then sends a packet containing both the TGT and the session key. This packet is then encrypted by the user's private key and sent back to the client. The client then decrypts the packet using the user's own private key from login to gain access to the contents of the packet. But what is the point of a TGT when the client is unable to view its contents? Well, it's more what they do with the TGT than what it actually contains. The client starts by creating an authenticator. This authenticator contains the user's name, the client IP, and the time. It then encrypts the authenticator with the session key and places this in a new packet along with the TGT and the name of the service that's required. The packet is then transported to the KDC. Once with the KDC, it can decrypt the TGT with its own private key. Knowing the TGT can't have been tampered with as it has not been opened, it can use the contents to access and check the information within the authenticator. Once the KDC has confirmed the user's identity, it can create a service ticket for the requested service. The service ticket is valid for just this user and the requested service for a set period of time. The service ticket contains the user's name, the requested service, the client's IP, and a new session key. The KDC then encrypts this service ticket with the service's private key. Similarly to the TGT, the client does not have a copy of the service's private key and will not be able to access the contents of the service ticket. The KDC then sends an encrypted packet using the first session key containing the service ticket – and a copy of a new session key back to the client. The client then can decrypt the packet and access its content. Now the client has the service ticket, all that is left is to gain access to the service. The client creates a new authenticator and encrypts it with a new session key received from the KDC. It then sends this authenticator to the Kerberos service along with the service ticket received from the KDC. Using the service's private key, the Kerberos service can decrypt the service ticket. Knowing it can't have been tampered with since being created by the KDC, it can use the session key contained in the service ticket to decrypt the authenticator and confirm the identity of the client using information from the service ticket. Now the identity of the user has been confirmed, a confirmation is sent back to the client and the user can access the service. Now we know how Kerberos works, we can start to understand the security behind it. To add to the security of not transferring passwords across a network, Kerberos servers keep a log of the packets that are received and once accepted cannot be used again. Also, as we've seen, Kerberos uses timestamps on tickets that are created, which means that even if a ticket is compromised, it is very unlikely that it can be used to gain access to your data. These timestamps become invalid if are more than 5 minutes off. This means that all servers and client machines need to be using the same clock. This is usually achieved by using a network time server to help guarantee that all machines are referring to the same time. Unfortunately, sometimes the security features of Kerberos can be its downfall, especially when dealing with expired tickets. Most of the time, expired tickets are replaced, but on the odd occasion, it may be necessary that you need to manually view, add, and remove these tickets. We can do this a few ways. Firstly, we can use the Ticket Viewer application. This can be found within Keychain Access's menu bar, or you can navigate to it through the Finder in System, Library, Core Services. Once open, Ticket Viewer gives you access to manage your ticket granting tickets, as well as view all tickets for each Kerberos user. We can use Ticket Viewer to create a new TGT for a user. To do this, you will need to authenticate as a user, which is known by the KDC. We can also use Ticket Viewer to remove a user's TGT. There is also an option to view diagnostic information about an identity and view all that user's tickets. To get this information, we can use the Command and I key combination or go through the ticket option on the application menu bar and select diagnostic information. We can also troubleshoot Kerberos tickets from within the command line. We can do this using the terminal application found within Applications Utilities. We can use the klist command to view the current user's ticket granting and service tickets. The klist command also has a few useful options. klist space minus lowercase l will list all currently cached Kerberos users and the expiry of their TGT. The klist minus uppercase a command will allow you to see all those same cached users, but this time view all of their current ticket information. The kinit command, along with valid user identity and authentication, allows you to generate a TGT from the KDC. Once run, the command gives no verification that it has completed, and will just give a command prompt. It is advisable to verify that the identity was created by using the klist command again we covered earlier. Lastly, we can use the kdestroy command. This will remove all the current users' tickets. As you can see from the slide, this has only removed tickets for the add user 1 identity. If you wish to remove all tickets from a client machine, this can be done by using the kdestroy space minus uppercase a command. With this option, all tickets for all users will be destroyed, and as you can see, now both add user 1 and AMSYS no longer have any tickets cached on the client machine. I hope you have found this podcast informative, and on behalf of AMSYS Training, thank you for watching.